Welcome to lecture 2 of week 3 of this SWM course. Now I am covering further aspect of functional element of solid waste movement. In this lecture 2, the content will be as followed, shown in the slide. This is an informal waste recovery process in India, where the waste is collected from different sites using waste track pickers, inert waste buyers, waste dealers, etc. I will discuss this, and these waste are supplied to wholesaler for the recycling, etc. First is waste generation. The first stage of solid waste management begins with the waste generation at household, industries, commercial establishment, construction sites and institutions. Waste generation encompasses those activities in which materials are identified as no longer being of value and are either thrown away or gathered together for disposal. Waste generation is a crucial issue that impacts environmental sustainability, public health and resource management. Various factors influence the quantity and composition of waste generated globally. The four most significant factors affecting waste generation include population growth, urbanization, consumption pattern and technological advancements. These are the functional units which are contributing toward the municipal solid waste generation. These are household, institutional, commercial, construction site, road sweeping, as well as the retailers and shops. This table shows the source of solid waste generation, like residential includes single and multi-story houses and high-density apartment. Type of solid waste include food waste, rubbish, ashes and special material. The institutional contributes include schools, universities, hospitals, prisons, government centers, etc. Waste similar to residential and commercial is produced in these institutions. As far as the commercial outlet, it generates the waste which are from stores, restaurants, market, office building, hotels, auto repair shops, medical facilities, and type of waste include food, rubbish, ashes, demolition and construction waste, occasionally hazardous substances. The industrial site generates the waste from construction, fabrication, light and heavy manufacturing, refineries, chemical plants, mining, power plant, demolition, etc. And the type of waste include food, rubbish, ashes, demolition, construction waste, special waste and hazardous waste, etc. The population growth and waste generation. First is increase in total waste volume. As the global population is increasing, so the amount of waste generated is also increasing. More population results in higher consumption of resources, leading to greater amount of soil waste, liquid as well as hazardous waste. According to the World Bank, global waste production is expected to reach 3.40 billion metric ton annually by 2050 if current trend is continued. Next, higher demand of consumer goods. A growing population increases the demand for food, clothing, housing and electronics, which is in turn lead to higher waste production, more packaging material, disposal items and used product contribute to the accumulation of solid waste. Next is pressure on the waste management system. Rapid population growth places an immense pressure or strain on the existing waste collection system as well as the disposal infrastructure. Many developing countries struggle to manage the increased volume of waste due to inadequate waste collection system, limited landfill space and insufficient recycling facilities. Next is health and environmental implications. With higher waste generation, risk of pollution, land degradation and water contamination increase. Improper waste disposal contribute to air and soil pollution, affecting human health and biodiversity, and also it leads to the food chain contamination. Urbanization and its role in waste generation. Urbanization refers to the migration of people from one place to another, especially from rural areas to cities, leading to expansion of urban spaces and an increase in municipal solid waste generation. Over 55% of world population lives in urban centers, a number projected to rise by 68% by 2050 according to United Nations report in 2018. The urbanization results in increase in municipal solid waste. The urban area generates significantly more waste per capita compared to the rural one. Due to the lifestyle disturbance, cities have higher level of packaged food consumption, single-use plastics and non-biodegradable waste. The quantities, quality and Composition of certain types of solid waste varies seasonally also. For example, the growing season of vegetable and fruit affect the quantity of food waste. Next is industrial and commercial waste. Urbanization also lead to economic growth, industrialization and the expansion of commercial activities. These sectors contribute significantly to hazardous and non-hazardous waste, including electronic waste, construction debris and chemical residue. Next, limited land for waste disposal. As cities are expanding, land available for waste disposal becomes scarce. Many urban centers struggle for landfill overcapacity, leading to illegal dumping and environmental pollution. Land is limited and is under tremendous pressure for food, shelter, industrialization, hence judicious use of land is desired. Next is changing lifestyle and convenience culture. Urban residents often rely on convenience-based products such as take-out food, bottled beverage and disposable household goods. These contribute to increased plastic waste and non-biodegradable material. Waste generally is strongly dependent on local economy, lifestyle and infrastructure also. It has been well established that waste generation of an area is proportional to average income of the people of that particular area. It is also observed that generation of organic, plastic and paper waste is high in income areas. Next, infrastructure and policy changes. Developing urban waste management infrastructures require significant investment. Many cities lack efficient recycling system, waste to energy plants and proper waste segregation at the source. Next is consumption pattern and waste generation. The consumption pattern significantly influence the waste generation. Economic prosperity, cultural trend and market driven demand shape consumer behavior, directly affecting the volume and type of waste produced. Geographical situation and consumption patterns strongly influence the waste production. Next is economic growth and affluence. Higher income level often lead to increased consumption of packaged goods, fast food, electronic gadgets and luxury items. The demand for novel products leads to faster disposal of old items, contributing to e-waste and textile waste. Economic growth and affluence are generally positively correlated with waste generation. As economies grow and individuals become more affluent, they tend to consume more goods and services, leading to increased waste production. Next is shift towards disposal products. Modern consumer culture favors single-use plastics, disposable cutleries and packaged food. The convenience of disposal items lead to greater waste accumulation in landfill. Next, food waste and overconsumption. Household, restaurants and supermarkets generate large amount of food waste due to over-purchasing, poor storage and expiration of products. According to Food and Agriculture Organization, 1/3 of all food produced globally, which is approximately 1.3 billion tons, is wasted each year. Food waste occurs at various stages of supply chain, from production to consumption. At the consumer levels, behavior and attitude also play a significant role in food wastage. These include over-purchasing, poor meal planning, misunderstanding date levels, and a culture of disability. A lack of awareness about the impact of food waste and how to store and use leftovers properly contribute to this problem. Next is advertising and plant obsolescence. Manufacturers and advertisers encourage frequent upgrades of electronic devices and fashion trends. Plant obsolescence lead to shorter lifespan of products, increasing e-waste and textile waste. Next is cultural and regional differences. Consumption habits vary across cultures. For instance, some countries emphasize repair and reuse, while others rely on fast fashion and mass consumption. Next is technological advances and waste generation. Technological progress has a dual impact on waste generation. While some innovation help in waste reduction and recycling, others contribute to increased waste production. Overall, the impact of technology on waste generation is double-edged sword, requiring careful consideration and proactive measures to mitigate negative effects should be taken. Next, rise of electronic or e-waste. The rapid advancement of consumer electronics, smartphones and home appliances has led to surge in e-waste. Many electronic devices contain hazardous substances such as lead, mercury and cadmium, requiring specialized disposal and recycling processes. The rise of electronic waste, e-waste, is primarily driven by several factors such as increasing consumer demands for newer, more advanced electronic devices. Rapid technological advances lead to shorter lifespan of electronics and lack of effective recycling infrastructure and practices. Next is automation and industrial waste. Advanced manufacturing techniques generate industrial waste, including chemical byproducts, scraps, and hazardous waste. Automation and robotic reduce some waste production but can lead to job losses and increase electronic waste from obsolete machineries. Waste management technologies. Technological advancement in waste processing such as waste to energy plants, composting technologies, and advanced recycling system help in reducing on landfill dependency. A smart waste collection system using IoT, that is Internet of Things, and AI, which is artificial intelligence, improve waste segregation and collection efficiency. Next, digital revolution and paper waste reduction. The shift toward digital communication has reduced paper waste in offices and educational institutions. However, digital consumption has led to increased energy consumption and electronic waste generation. The amount and type of waste generated globally are influenced by multiple factors, including population growth, urbanization, consumption pattern, and technological advancements. These factors shape the way resources are consumed and discarded, impacting waste management systems worldwide. To mitigate the environmental impact of rising production, strategies such as waste reduction, recycling, sustainable consumption, and technological innovation must be promoted. By adopting a circular economy approach, society can transit towards sustainable waste management, minimizing landfill waste, and optimizing resource recovery. Effective policies, public awareness, and infrastructure development are key for addressing waste management or waste generation challenges and ensure a cleaner and healthier environment. After waste generation, on-site handling and storage and processing. On-site means these functions are concerned with solid waste at the place where waste is generated. On-site handling is the very first step in the waste management. It involves individual family members, household, and communities, all of whom need to know how to handle waste properly at this level. Waste is temporarily stored at a source before collection. Household and businesses use dustbins, garbage bags, or compost pits for segregation. On-site processing can help reduce transportation costs. These are the recycle bin containers which can be used for source segregation at the generation point. Next is collection. Waste is collected by municipal authorities, private contractors, or waste management firms. As far as the method of collection is concerned, they follow either door-to-door collection, or they use community bins, or the waste is collected by street sweeping. The effectiveness of collection depends on waste segregation, infrastructure, and frequency of collection. Primary collection of waste is second essential step of solid waste management activity. Primary collection system is necessary to ensure that waste stored at source is collected regularly and it is not disposed of on the street, drains, water body, etc. However, a step has to be synchronized well with the first step, that is the storage of waste at the source. The frequency of collection depends on the quantity of waste, time of the year, socio-economic status of the area served, and the municipal or contractor responsible for that. Tools and equipment used in collection of solid waste. Collection and transport of solid waste involve use of variety of tools, equipment, and facilities. It is essential that these are selected with due care so to ensure optimal performance of the system. Most of the tools and equipments that are currently being used have not been especially designed for solid waste collection work and are often adopted because they are readily available for some other services. To improve performance of the system, following tools and equipment should be used for storage, collection, and transfer of solid waste. First, brooms. Second, shovels. Third, mechanical sweepers. Fourth, hand carts. 5. Household storage. 6. Commercial storage. 7th, street waste storage. 8th, community bins. Now to transport. The waste collection in storage containers or community bins are carried to the processing or disposal site by using a variety of vehicles. If transportation vehicles are selected properly, then transportation cost can be reduced substantially. Also, transportation should use or transport route should be properly decided using remote sensing and GIS to avoid rush and human intervention. Process and recovery. Waste is processed to recover valuable material, energy or organic matter. Method of recovery. Material recovery facilities are there where sorting and processing of recyclable is done. It can also be done by composting, anaerobic digestion, recycling or incineration, whatever the process is suitable for that. The obstacle for the resource recovery. First obstacle is heterogeneity of waste, because the waste is not homogeneous in nature, so it is a very big problem to decide the methodology. Potentiality of the waste. As the waste comes in the contact of water or humidity, it is most of the content is biodegradable nature. It is start by degradation and smell and fouling smell comes. So this type of waste needs to be put in attention as soon as possible. Location of the waste. Low value of the product. Uncertainty of supply, because the waste volume is not fixed. It varies season to season. It has the temporal variation also. Unproven technology. Administrative and industrial constraints, legal restriction and uncertain market. This is a table which shows the different waste disposal method, its advantage and disadvantage. The most favored some of the options of waste disposal are ocean dumping, sanitary landfill, incineration, open dumping as well as recycling. The advantage of open dumping is it is convenient, inexpensive and it may be served as a source of nutrients, shelter and breeding. As far as the disadvantage is concerned, oceans are overburdened, destruction of food resource in water body, killing of plankton and it may lead to desalination of the ocean water. The sanitary landfill has the advantage because volume can increase with little addition of people or equipment, fill the land with reuse or other community purpose. Whereas disadvantage is that complete landfill areas can settle and require maintenance, require proper planning, design and operation. Also the advantage is in the sanitary landfill is the landfill gas, which can be used as a renewable energy source. As far as the incineration is concerned, the advantage requires minimum land, can be operated in any weather, produce stable odor-free residues and refuse volume is reduced by half. Whereas the disadvantage is concerned is expensive to build and operate, high energy requirement, required skilled person and continuous maintenance. Also the smell and toxic gases emission from the incineration process is a major problem due to the human health issue concern. The open dumping advantage is inexpensive, very easy to handle. If the disadvantage is concerned is it poses health hazards, attract insect and rodents. It also leads to damage due to air pollution. It also contaminates the groundwater and also leads to runoff pollution. Also it has the aesthetic problem of the site. Now the recycling. The recycling has the advantage because it is key to provide a livable environment for the future. Whereas the disadvantage is concerned is it is expensive process. Some waste cannot be recycled at all. Technological push need is desired. Separation of useful material from waste is difficult. This table shows the relative metrics of various disposal options of the waste. You can see if you go for the volume reduction, it is non-injured disposal, sanitary, and it can only go for the incineration. If you talk about the non-injured disposal, it is long-term maintenance required and adaptability of waste is also okay and adverse environmental impact is there. If you talk about the sanitary landfill, there is no volume reduction, but it is expensive, long-term maintenance required, byproduct recovery is there in form of landfill gas and adaptability to all wastage is there. And adverse environmental impact is very little. Whereas composting is concerned, it is expensive, with no maintenance, byproduct recovery in form of the compost is there. Whereas incineration, volume reduction is there, expensive process, byproduct recovery in form of ash or the gas is there. But sometimes the ash contains the heavy metal and it is not suggested to be used. Key insight and strategy for effective solid waste management. First is waste reduction as source. The waste reduce consumption, encourage consumers to buy only what they need and opt for products with minimal packaging, promote sustainable practices, emphasize the 3 R's to minimize waste generation, product design, advocate for better product design that minimize waste generation and promote durability. Next is reuse and repurpose, find alternative use. Encourage the item before discarding them. Repurposing, convert waste material into new useful items such as repurposing old cloth into craft material or using old tires as planters. Third is composting gardening waste. Composting programs, establish composting programs at homes, business and communities to convert gardening waste into nutrient-rich compost for gardening and agriculture. Fourth is recycling and resource recovery, proper sorting and segregation. Implement effective sorting and segregation system at the source, ensuring that recyclable materials are properly separated for efficient recycling. Next is waste to energy plants. Invest in waste to energy plants to convert waste into useful energy, reducing the need for landfill disposal. Next is circular economy. Embrace circular economy principle by turning waste into valuable resource, creating closed loop system where waste become a new resource. Next is responsible disposal. Landfilling should be last resort and only for waste that cannot be recycled for or converted into energy. Next is hazardous waste management. Ensure the proper collection, storage and disposal of hazardous waste to prevent environmental and health risks. Next is incineration. Consider incineration as a viable option for reducing waste volume and treating hazardous waste but with proper emission control. Next is public engagement and education. Community participation. It involves the public and solid waste management initiative through awareness, campaign, educational programs and community events. The public-private partnership. Collaborate with private companies and NGOs, that is non-governmental organizations, to enhance the efficiency and sustainability of waste management efforts. Seventh is technology and innovation. Smart waste management. Implement smart waste collection and management technologies including GPS-equipped garbage trucks, automated sorting system. Next is technological advancement. Support this research and development of new waste management technologies such as advanced recycling processes and waste to energy technologies. Next is policy and legislation. Waste management policies. Develop and implement effective waste management policies that incentivize waste reduction, reuse and recycling. Next is addressing local context, tailored solution. Recognize that different cities and regions have unique waste generation and composition, geography, climate and cultural factors. Therefore, one size fits all approach to waste management is not effective. City-specific challenges. Identify and address the specific challenges and gap in each city's waste management system, such as inadequate infrastructure, lack of awareness and enforcement. This is a table showing very well the challenges to improper waste management in developing countries where lack of finance competence lead to struggle for facility upkeep, inadequate technical capability result in failure of design plan for waste management, lack of enough staff lead to different mismanagement, change in administration often lead to halting of various projects, workers are underpaid and at a high risk of injuries and disease, limited communication among various stakeholders is a major barrier for the proper waste management, and lack of efficient techniques of waste handling concerning geography and topography of location, and the cultural preferences often complicate waste disposal because India is a country where there are different festivals in different seasons, so the waste generation is also vary with the cultural events also. This figure shows the comparison of linear economy, recycling economy and circular economy. You can see the linear approach here, second is the recycling and third is the circular economy for raw material to products. This is the slide showing the references which were used for further study as well as the preparation of the slide, and thank you all for paying your kind attention. Thank you.